Given the function f of x equals 2 times the square root of the quantity 3 minus x, determine the domain and then graph the function. Recall the domain is the set of all possible inputs or x values. In this case, because we have a square root function, in order for the function values to be real, the radicand must be non-negative, indicating 3 minus x must be greater than or equal to 0. Solving this inequality will give us the domain. So again, starting with 3 minus x greater than or equal to 0, we need to solve for x. Let's first subtract 3 on both sides, which gives us negative x greater than or equal to negative 3. And now to solve for x, we need to either multiply by negative 1 or divide by negative 1. But whenever we multiply or divide by a negative when solving an inequality, we must reverse the inequality. So we'll go ahead and divide both sides by negative 1, but again also reverse the inequality. Simplifying, we have x less than or equal to 3. This is a domain expressed as an inequality. Let's also graph the domain on the number line. Three is in the interval, and therefore we have a closed point on 3. And because we have x less than or equal to 3, we have an arrow to the left. And notice as we move to the left, we approach negative infinity. And now let's express the domain using interval notation. We have the interval from negative infinity to 3. We use a parenthesis to the left of negative infinity, and we use a square bracket to the right of 3 because the interval is closed on 3 or includes 3. We now have the domain expressed using an inequality, a graph, as well as interval notation. And now let's work on graphing the function as a transformation of the basic square root function shown below. Recall, any transformation of the basic square root function can be written in the form of f of x equals a times the square root of the product of b and the quantity x minus c plus d, where the values of a, b, c, and d will tell us the type of transformation. In order to write the given function in this form, though, we are going to have to change the form of 3 minus x. 3 minus x is equal to negative x plus 3, and if we factor negative 1 out, we can write this as negative 1 times the quantity x minus 3. This indicates we can write the given function as f of x equals 2 times the square root of the product of negative 1 and the quantity x minus 3. And now we can identify the values of a, b, and c. We have a equals 2, which indicates a vertical stretch by a factor of 2. b equals negative 1, which indicates a horizontal reflection. And c equals positive 3, which indicates a shift right 3 units. And now let's graph the given function by performing these transformations on the basic square root function below. Let's start with b equals negative 1, which indicates a horizontal reflection, or a reflection across the y-axis. To graph this reflection, we can take key points on the graph of the basic square root function and multiply the x values by negative 1. So for the point 0, 0, the corresponding point is still 0, 0, because 0 times negative 1 is still 0. For the point 1, 1, the corresponding point is going to be negative 1 times 1, 1, or negative 1, 1. The corresponding point for 4, 2 is negative 1 times 4, 2, or negative 4, 2. Let's go ahead and graph what we have so far. This is the graph of the basic square root function after a horizontal reflection. And now because c equals 3, we'll shift the graph after the horizontal reflection right 3 units, which also affects the x values. We'll now add 3 to these 3 key points on the function after the horizontal reflection. The corresponding point for 0, 0 is 3, 0. The corresponding point for negative 1, 1 is negative 1 plus 3, 1, or 2, 1. And the corresponding point for negative 4, 2 is negative 4 plus 3, 2, which is negative 1, 2. And now let's graph this function. This is the graph of the basic square root function after it's been horizontally reflected and shifted right 3 units. And finally, we have a equals 2, which is a vertical stretch by a factor of 2. This affects the y values, we now take these 3 key points and multiply the y values by 2. For the point 3, 0, because 0 times 2 is still 0, the corresponding point is still 3, 0. For the point 2, 1, the corresponding point is 2, 2 times 1, or 2, 2. And finally, the corresponding point for negative 1, 2 is negative 1, 2 times 2, or negative 1, 4. And now we finally have the graph of the given function f of x. This is the graph of the basic square root function after being horizontally reflected, shifted right 3 units, and then vertically stretched by a factor of 2. Let's also verify this using Desmos. Right now we see the graph of the basic square root function, and now we will change b to negative 1 to see the horizontal reflection, which is the red dashed graph. Next we'll change c to 3, which shifts the graph right 3 units. And finally we'll change a to 2, which will vertically stretch the graph by a factor of 2. And notice we do have the key points 3, 0, 2, 2, and negative 1, 4. I hope you found this helpful.